Welcome to This Day in His Story, created by American Heritage Worldwide, a reminder that every day holds something new to learn. Did you know that the Hubble Space Telescope is powered by energy from the sun and orbits the Earth at about 17,000 miles per hour? Learn how Hubble is expected to keep working and making discoveries until around 2030 to 2040. Discover that the crew of the Discovery placed the Hubble Space Telescope into a low orbit around the Earth, and it is fully operational, producing groundbreaking science, taking pictures of stars, planets, and galaxies. Imagine for a second that you are hitching a ride on a machine powered entirely by the sun.
Just floating out there.
Right. You are hurtling through the freezing vacuum of space, completely weightless, and, moving at a staggering speed of 17,000 miles per hour.
Which is just, it's hard to even wrap your head around that speed.
It really is. But your mission on this machine isn't just to float around and take pictures. Your mission is to peer out into the absolute darkness, to look right up to the very edge of the universe itself, and to discover the profound, ultimate truths hidden out there in the deep.
Because the Hubble Space Telescope is not just a high-tech camera floating around in low Earth orbit.
No, absolutely not. Welcome to today's deep dive, everyone.
Yeah, glad to be here.
Today, we are taking you on a journey aboard that very telescope. And we're pulling from a really fascinating stack of sources for this one.
We really are. We've got excerpts from a document called Hubble, a Celestial Witness of the Universe.
Such a great title.
It is. And we're pairing that with some supplementary educational resources from NASA, plus insights from this great little video titled How Hubble Works.
Because, as you were saying, Hubble is arguably one of the most important tools humanity has ever created for learning about reality.
Exactly. It didn't just capture pretty celestial landscapes. It fundamentally redefined our understanding of distance, our grasp of time, and really our own place in the cosmos.
Okay, let's unpack this. Because the story of Hubble is not, a straightforward victory lap.
Far from it.
Right. Before this machine could unlock the deepest secrets of the cosmos, before it could reshape modern astrophysics, it was almost a complete multi-billion-dollar catastrophe.
A very public, very intensely scrutinized failure, actually.
Yeah.
To understand how it got its unparalleled vision, we really have to look at the drama of how it got off the ground.
So, April 25th, 1990.
Right, 1990. The telescope was deployed from the cargo bay of the Space Shuttle Discovery. And the core idea behind the mission was just brilliant. Put an observatory above the Earth's atmosphere.
Because down here on the ground, the air we breathe actually distorts light, right?
Yes, exactly. It's the whole reason stars appear to twinkle. Yeah. So, by putting a telescope 340 miles above the Earth, NASA could bypass that distortion entirely.
And they named it after Edwin Hubble, which makes perfect sense when you look at the history.
Oh, absolutely.
Back in the 1920s, the scientific consensus was that the Milky Way galaxy was basically the entire universe.
Right, they thought that was all there was.
Yeah. Whenever astronomers saw these fuzzy patches of light in the night sky, they just assumed they were local clouds of gas. But Edwin Hubble was the one who proved those clouds were actually entire other galaxies.
He essentially broke the boundaries of the known universe.
He proved it was infinitely larger than anyone had previously imagined. So NASA names this monumental piece of technology after him. They launch it. Scientists around the globe are holding their breath, waiting for these revolutionary pictures to beam back to Earth.
The anticipation was huge.
And then the first images come in.
Yeah.
And they are completely blurry.
It was a devastating moment for everyone involved. The issue came down to a microscopic flaw in the primary mirror of the telescope.
Microscopic.
Yes. And when we say microscopic, we have to emphasize just how precise these instruments are supposed to be.
Right.
The mirror was 2.4 meters across, and it was polished to be the smoothest large surface ever created by human hands.
Wow.
If you scale that mirror up to be the size of the Earth, the tallest bump on its surface would be only about 6 inches high.
Okay, so wait. How does a mirror that unbelievably perfect end up ruining the images?
Because of a phenomenon called spherical aberration.
Okay.
The mirror was perfectly smooth, yes, but it was polished to the completely wrong shape.
Oh, no.
Yeah, the edges of the mirror were flattened by a microscopic fraction. We're talking about 1/50th the thickness of a piece of paper.
That is insane.
But when you are trying to capture light that has been traveling across the vacuum of space for billions of years, A microscopic error is all it takes.
Hmm.
The light rays didn't bounce off the mirror and converge to their single focal point. They just scattered.
So imagine waiting years and spending billions of dollars on the ultimate 4K television.
Right.
And you finally get it home, you plug it in, and you realize the manufacturer installed a blurry screen.
It's the ultimate letdown.
Yeah, but to fix it, you can't just put it in a box and return it. You have to send a repair crew into the lethal vacuum of space. I mean, how do you even approach fixing an optical flaw on something traveling at 17,000 miles per hour?
Well, what's fascinating here is the sheer human ingenuity required. It took NASA over 3 agonizing years of preparation to figure out a solution.
30 years.
Yeah. Finally, on December 2nd, 1993, they launched a dedicated repair mission on the Space Shuttle Endeavour. 7 astronauts went up there, and over the course of 5 grueling days of spacewalks, they essentially gave the telescope corrective glasses.
Doing microscopic optical surgery while wearing pressurized, bulky spacesuits?
Right.
It sounds impossible.
It really does. But they installed a system called CoStar. It was roughly the size of a telephone booth.
A telephone booth?
Yeah, and it contained a series of tiny, perfectly calibrated mirrors. These mirrors intercepted the flawed light bouncing off the main mirror, corrected the spherical aberration by acting exactly like a pair of contact lenses, and then fed that focused, crisp light into Hubble's cameras.
Wow. And that fixed the immediate crisis. But what really stands out in the sources is the longevity of the mission.
Exactly.
They didn't just fix it and leave it alone. The space shuttle crews went back up there for 5 different servicing missions over the years.
They did. They constantly swapped out old parts, installed new cameras, upgraded the technology.
Because of those incredibly dangerous spacewalks, fixing a mirror moving at 17,000 miles per hour, powered only by the sun, they turned a near disaster into decades of groundbreaking observation.
It's expected to provide information well into the 2030s or even 2040.
Amazing. But once the glasses were fixed during that 1993 spacewalk, humanity finally got a clear view.
A very clear view.
So what exactly did those new cameras beam back to Earth?
Well, perhaps no image is more famous than the photograph known as the Pillars of Creation.
Oh, yeah. Even if you don't know the astronomical name, you've seen it.
Everyone has seen it yet.
It looks like these massive, majestic columns of dark smoke or clouds just illuminated from the inside out.
Those pillars are located in the Eagle Nebula, and they are literal towers of cosmic dust and gas. But what is truly hard to grasp is the sheer physical size of what you're looking at in that photograph.
Right.
Those columns stretch a massive distance of 4 to 5 light years long.
Okay, wait. I need to jump in here and ask a pointed question on behalf of everyone listening because this always trips me up.
Sure, go ahead.
When we look at the pillars of creation, or any of these famous Hubble photographs, they are bursting with these vibrant, glowing neon blues, deep reds, and bright greens.
They're very colorful.
Are those real? Like if I were floating outside a spaceship right next to the Eagle Nebula, looking out the window, is that the exact visual I would see, or is Hubble giving us a cosmic paint by numbers?
That is the perfect question to ask, because the naked human eye would absolutely not see those vibrant neon colors.
I knew it.
Yeah, the colors in Hubble photographs are highly scientific. They aren't just for show. They are specifically coded to map out the chemical elements present in those structures.
How does that actually work, though? How does a telescope act like a chemical detective and detect individual chemicals from trillions of miles away?
It all comes down to how different elements behave when they get incredibly hot.
Okay.
Inside those pillars, the intense radiation from nearby young stars is heating up the surrounding gas. And when the atoms in that gas get excited, they start to glow.
Makes sense.
But here is the critical mechanism. Every single element in the universe emits light at a very specific, unique wavelength. It acts like a chemical fingerprint.
So oxygen gives off a totally different wavelength of light than sulfur does.
Exactly. Hubble's cameras are equipped with special filters, only letting specific wavelengths of light through.
Oh, that's a great way to put it.
Thanks. So when scientists get the data back, they isolate the specific wavelength emitted by oxygen, and they assign the color blue to it.
Okay.
They take the wavelength emitted by sulfur and assign the color red. And they take the light emitted by nitrogen and hydrogen, and they assign the color green.
Wow. That completely changes how I view those pictures.
Right.
They aren't just beautiful art pieces. They are detailed elemental maps. It's reading the atmosphere of the universe.
Exactly. When astrophysicists look at the pillars of creation, they aren't just admiring a shape. They look at the blue areas and see exactly where the oxygen is concentrated. They look at the red and see where the sulfur is gathering.
That's incredible.
And those killers are stellar nurseries. There are regions where raw gas and dust are actively clumping together under the force of gravity, eventually building up enough pressure to ignite nuclear fusion and form brand new stars.
So, by color-coding the elements, scientists are watching the literal building blocks of the universe in action.
The raw science is translated into visual beauty.
It's staggering. But, understanding the composition of the universe, finding out where the oxygen and sulfur are hiding is really only half the story.
Definitely.
Because Hubble's real gift, the thing that truly strains the limits of human imagination, is how it shows us the staggering scale of what is out there.
Yes.
Let's zoom out from the Eagle Nebula for a second.
We have to, because the math we start dealing with quickly becomes almost impossible to picture in your head.
Well, let's try to ground it. Earlier you mentioned the pillars of creation are 4 to 5 light years long.
Right.
A light year is simply the distance that light travels in one single Earth year. And since light moves at about 186,000 miles per second, it covers a massive amount of ground. One single light year is roughly 6 trillion miles.
6 trillion. That is a 6 followed by 12 zeros.
Let me put that into a more human perspective. If you were traveling in a standard commercial airplane, flying at about 500 miles per hour, it would take you over 1.3 million years just to travel a single light year.
Just one.
Just one. And that 6 trillion mile measuring stick is just the baseline. Let's look at what Hubble found when it pointed its lens at a star cluster called Messier 3.
Oh, yeah?
This is one of the brightest and largest clusters of stars in the entire sky. It sits roughly 33,900 light years from Earth.
So that is 33,900 multiplied by that 1.3 million year airplane ride.
My calculator just gave up and started smoking.
Right.
But here's where it gets really interesting, because even that is just a local neighborhood compared to the rest of the data.
It is.
Hubble also studied a galaxy known as M87. This is the largest member of something called the Virgo cluster. Now, the Virgo cluster itself contains nearly 2,000 different galaxies.
A massive area.
Yes, and M87, just this one single galaxy within that massive cluster, contains roughly 15,000 distinct star clusters.
Unbelievable.
It holds a supermassive black hole at its center, and it contains several trillion individual stars.
Trillion. Again, a number with 12 zeros.
Yeah.
Just in one single galaxy out of thousands in that specific cluster.
I really want you to try and visualize that. I want everyone listening to imagine a single galaxy containing 15,000 different families of stars and trillions of individual suns all swirling around a central point.
Hard to grasp.
It's a scale that makes our entire solar system, the Earth, the Sun, Mars, Jupiter, it makes it all feel entirely microscopic.
It really brings us full circle to Edwin Hubble's original discovery.
How so?
Well, before him, we thought we were the center of a very small local universe. The Hubble Space Telescope has shown us a universe teeming with entire families of thousands of galaxies, fundamentally reshaping humanity's understanding of our physical insignificance.
We are microscopic, yes. But here is the massive turn in the story laid out by our sources.
Right.
Because we have all these awe-inspiring images of supermassive black holes and trillion-star galaxies and gas pillars mapped out in neon colors.
The breathtaking math and scale.
Exactly. So what does this all mean? What is the ultimate truth behind all this data?
Our source text, Hubble, a celestial witness of the universe, makes a direct connection here. It takes all of these scientific observations, the distances, the chemistry, the precise orbits, and explicitly state that they reveal a direct spiritual reality.
It points straight to the divine.
Yes. The author turns our attention to a specific scripture from the Book of Mormon, Alma chapter 30, verse 44.
I have that exact text from the sources right here, actually, because it frames this entire point perfectly. It says, "Yea, and all things denote there is a God. Yea, even the earth, and all things that are upon the face of it, yea, and its motion, yea, and also all the planets which move in their regular form, do witness that there is a supreme creator."
And that is the core truth the source is presenting. These physical phenomena, these impossibly complex images captured by Hubble, stand as an undeniable witness to a supreme creator.
Right.
The telescope isn't just adding to our scientific knowledge of chemistry and physics. It is actively testifying of Heavenly Father and Jesus Christ.
When I try to synthesize this, I think about a specific analogy. Think about walking into a museum and seeing a painting that is impossibly intricate.
Okay.
The colors are perfectly balanced. The perspective is mathematically flawless. The brush strokes are just pure genius.
Masterpiece.
Exactly. You don't need to see the artist standing right there in the room to deduce that the painting didn't just accidentally assemble itself. The sheer precision of the painting itself is absolute proof of a master painter.
If we connect this to the bigger picture, that is exactly what the cosmos is showing us. Think about the regular, perfect motion of the planets mentioned in that verse.
Yeah.
Think about the fact that gravity perfectly balances a trillion-star galaxy like M87 so that it doesn't just fly apart.
Or even the fact that human beings can predictably orbit a machine at 17,000 miles per hour, powered entirely by the sun, to perfectly catch that light. The 17,000 mile per hour precision orbit is the literal signature of the supreme creator.
It is. The true value of Hubble isn't just in measuring a 6 trillion mile light year or finding oxygen in dust clouds.
Right.
By showing us the precise, regular form of the cosmos, it provides us with an undeniable celestial witness of Heavenly Father and Jesus Christ. Knowledge of science and knowledge of the divine are perfectly united in these images.
It's such a profound way to look at the night sky. To go from a struggling, blurry, flawed mirror in 1990 to an instrument that decodes the chemistry of the universe and testifies of its creator.
And doing so while hurtling through a freezing vacuum.
It really is a marvel, and the best part is, the story isn't over. Hubble is still up there, working flawlessly, ensuring its relevance until at least 2030 or 2040.
We still have years of discoveries ahead.
We do. And for you listening, if you want to see the actual mechanics of this incredible machine in action, there is a great video you can look up. It's just 3 minutes and 36 seconds long, and it's called How Hubble Works.
It does a fantastic job of visualizing everything.
It really does, and NASA has fantastic sites filled with these incredible high-resolution images, along with activities to help kids explore space.
Highly recommend checking those out.
Well, we have covered a massive amount of space today, literally and figuratively. From blurry mirrors to the signature of a master painter.
We certainly have. But before we sign off, there's one final provocative thought I want to leave you to ponder.
Let's hear it.
We started this journey by hitching a ride on a machine looking out into the dark. We've talked about galaxies with trillions of stars and pillars of creation. But remember, the Hubble Space Telescope is only capturing the light that has managed to physically reach its mirrors.
Just the light that makes it here.
Exactly. If the Hubble Space Telescope has revealed this staggering amount of truth about the Supreme Creator's work just by capturing the light that reaches its mirrors, what infinite wonders and truths are still waiting out there in the vast distances of space, just beyond our current field of vision?
Thank you for joining us for this day in His story. May the lessons of yesterday inspire you to see God's hand today and to play your part in His story now. For more faith-based learning, visit ahsworldwide.org, the homeschool for faith and family.